All right, we're back. Do I want to hide this stuff on the desktop? I don't know. Let's see. Who cares? All right, we're uploading that. Anyone? Bueller? Okay. Manage code. What is manage code? Let's see if Wikipedia can help us out. Indeed it can. I'm sure it's some ridiculous thing. Manage code is a term coined by Microsoft to identify computer program source code that requires and will only execute under the management of a common language runtime virtual machine, resulting in bytecode. This disambiguation is prevalent and only relevant when developing applications that interact with the .NET framework or other CLR implementations, such as Mono. Many older programming languages have been ported to the CLR. The differentiation is needed to identify managed code, especially in a mixed setup. Let's see if we can get something more relevant to us. Let's see, can produce managed code, yada, 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 blah, 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 blah. Programmer convenience, and enhanced security guarantees depending on the platform, slower startup speed, and generally increased use of system resources on any machine that's executed. We are interested, in fact, in JIT, just-in-time compilation, if you will, and we may end up looking at that. There are many examples of code. Yep, another source of confusion. All right, we're going to look at JIT. Just-in-time compilation, known as dynamic translation, is a method to improve the runtime performance of computer programs based on bytecode. Since bytecode is interpreted, it executes slower than compiled machine code unless it is actually compiled to machine code, blah, 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 blah. Will you just give me a key sentence so that I can sort of tie this up? Stored in memory, but the code segment currently is compiled to physical, blah, blah, blah. Hybrid approach, caching and translated code to minimize degradation. Not doing me any favors here, Wikipedia. All right. Here's what we're going to say. This is a bit of kind of what we're talking about right here, but we're going to go back. So manage code, we're going to define this on our own. I'm really glazing through this, so I mean, it's possible I'm missing some. If you pause the video and if I take a second, I could maybe. The manage code must be, yeah, it's got to be JIT. Generally, I'm sure. All right. So if you want to dive deeper into this and all the just-in-time compilation stuff, then you could read this article. We're not going to do that. Instead, we're going to just say manage code is a blanket term for the purposes of our informal series here, that it is only loaded. All right, so say we start up an application. That's a better way to do it. Let's start up the game. That's an even better way to do it. We start up the game. Is the entire game in memory right now? Well, according to sort of the classical interpretation, it must be in memory. Otherwise, we couldn't run the game. And we can maybe further sort of articulate this a little bit by going to, can we do that? Can we say show me that? No, we can't. We go to processes. We go to Shadowrun.exe. Wow, Firefox is using more memory than Shadowrun. Firefox has a real problem. Anyway, 205 megs for Shadowrun. Is that the entire game? Does this game only require 205 megs of memory? Probably not. Let's just click continue, see what happens. Let's watch this number. 265, 371, 389. Kind of topped out there a little bit. 389. Oh, no, I was looking at the wrong one. We're way up here. We're over half a gig now. So just clicking continue, the game is loading all sorts of assets and graphics and things like that. And it's not just assets and graphics. It's also loading the actual code for how to handle certain events. So like moving, how to move the character. Well, there's routines and all kinds of crazy code that determines how to move the character. And that stuff is not in memory until the game actually needs it. So if you're coming at this from the approach of, I want to hack the game and make it so my karma never goes down, or, I have infinite health or God mode or infinite ammo, whatever, crazy thing you want to do, when you're dealing with managed code, you have to be sure that that stuff is actually in memory, or you're never going to find it. And that is why it's awesome from a developer perspective, because all this stuff is kind of taken care of for you in a sort of abstract way where you don't have to say, load this, load that, or whatever. It's all just kind of taken care of for you by the CLR and .NET in general, or Mono as the case may be. And it gives you some performance boost. Obviously, there's some startup problems and things like that, but I wouldn't even call them problems. But for our purposes, we are making a blanket statement about when the game uses managed code, you have to force the game or be sure, however you're going to do that, we'll talk about that in a second, but you have to be sure that the game has actually loaded the parts that you're interested in hacking on into memory. Otherwise, you'll never find it, or you'll be chasing empty, pointer paths and writing routines and things like that are never going to have any effect on the game because those routines don't even exist, so you can't possibly find them. So let's see if we can we're using Shadowrun.exe, so we're going to use this. We're going to jump over to the Cheat Engine forums here. We're going to go to tables. We're going to look at the master himself. See, where's the game? It's around here somewhere. I scroll down too far. Where's the man who makes the tables? There it is. I don't know how to pronounce his name. Resifence, probably something like that. Here you go. The guy obviously knows what he's doing. He makes tons of tables. He makes tons of tables for awesome games, which I think is even more amazing. He has great taste in games. And cheers, sir, if you're watching. Let's read the usage notes here for a little bit. The table contains a script divided in 3 parts. Well, why the hell would you do that? Well, let's keep reading. Part 1, related to heroes' information and karma, related to heroes' action points and ammo, related to the hero's health. In order to load Part 1, you have to open Object Mission Info, Escape, or the PDA, and click on the character icon. Now you can load Part 1. In order to load Part 2, you have to enter into combat and shoot somebody. Now you can load Part 2. In order to load Part 3, one has to lose some HP from your team or the enemy. Now you can load Part 3. Why is it like this? Why does life have to be so difficult? Well, if you keep reading, you can get down here. Info. This game uses .NET Framework as the code is divided in parts that is only loaded when needed, which is exactly what we were just talking about and reading on Wikipedia with managed code in a somewhat indirect way. And games that use .NET it's certainly not impossible, but the reason that the scripts are broken out into different parts is because the general sort of generic approach with making cheat tables and whatnot is that you just have one massive control script. I wouldn't call it massive, but you have one large control script that you just enable, and then you have a bunch of Boolean flags that once the script's enabled, you go down there and you can enable the flags and whatnot. When you're dealing with managed code, you have to break that up a little bit in order to give the user some amount of flexibility so that if they say they create a new character, they're not going to drop into combat immediately, but maybe they want to mess around with their karma or whatever, or their money, as the case may be. You don't want to have to basically be like, well, you can't use my script until here's the laundry list of conditions you must have met. You have to be shot, you have to spend money, you have to move, and you have to open the PDA, and I don't know, there's probably one other one. You have to click on the character icon or something like that. This is why the script's broken up. I don't mean to single out this one. It's just that Shadowrun's the game that we're using for the series, and there's no way around it. It's just when you're dealing with managed code, you have to be aware that you have to trigger certain events in the game in order to get those parts of the game, the code or the memory or whatever, loaded into memory so that you can actually find it with Cheat Engine. Otherwise, Cheat Engine will never be able to find it. And that's just a function of managed code and the .NET framework in general. And how many games are written in the .NET framework? Quite a few, and it's becoming more and more popular. So this is something that people are just going to have to come to grips with. The Unity engine, I want to say, is getting pretty popular. A lot of games are written in it. I want to say Shadowrun's probably written in Unity. So how do you know that your game uses managed code? There's a couple ways, but this is just the way that I take. Yep. So you start up your game, you start up Cheat Engine, you attach Cheat Engine to the process. We're going to go to memory view. We're going to go to tools. And then we are going to go to dissect code. We're not messing around with anything else. We're not even searching for values. We're just going to go to dissect code. What's that? That's mono.dll. Well, what's mono? Mono is, as Wikipedia was telling us, like mono. Mono is a free and open source project led by some crazy thing to create an ECMA standard compliant .NET framework compatible set of tools, including a C# compiler and a CLR. Well, we already know that the CLR produces managed code using some combination of just-in-time compilation and other crazy things. So whenever you see like mono.dll or whatever, some .NET libraries or something like that loaded, you're probably, is it guaranteed? I don't know enough about it to say that it's guaranteed, but more than likely you are probably dealing with some managed code, and you need to just really think about what you're doing before you start looking for values. So let's just make a new game. And let's just show how it's going to be. We're not going to go through the whole thing, but I just want to sort of demonstrate. Like when I first started messing with this game, this is how I dealt with it. I started to suspect that the game was managed code. I did dissect code. I looked at the different variants and DLLs loaded. And I was like, okay, so we're dealing with managed code. So I knew that I had 34 karma. Now let's pretend that we just loaded the game and didn't click on the PDA. Am I going to immediately alt-tab back out here and search for 34? No, because there's the player information or whatever. It may not be, or the routines more specifically that I wanted to find and then override by code injection may not be in memory. So I would click here first, and then to be even more sure, I would click here, and then I would click here. And only then, once I was on this screen and I knew that I would even actually, to be honest, I would even spend a point to be like, all right, now I know everything's in memory, or I suspect it is. That's how I do it, is I would basically walk the chain of menus all the way to the end until I was sure that there was no other menu that I could get to that had to do with karma. And then I would say, and then in my head, or just to my own intuition, I felt comfortable saying, okay, the values are in memory. I'm good to go. I can start searching and pointer scanning and overwriting, code or routines and things like that in memory. So let that be a lesson, or not a lesson. That's too ridiculous. But let that be a warning that if it's managed code, know what you have to do to deal with it. And the rule of thumb is you have to make sure that the code is in memory via executing or triggering certain events that force that code to be run at least once. If you have already gone into a menu, and you may not have to go back into the menu a second time in order to get it to load, or cheat engine to find it, but always just, you may have to, you may not have to. It all is. I realize that sounds crazy. That, how can you say that you might have to and you might not have to? Because it's just really, really tricky. I don't know any other way to say it, and it varies from game to game. On some games, you may not have to reopen a menu in order to have cheat engine or pointers work. In other games, you may have to, or you may not have to. It just is totally game dependent. And when you're working with a .NET or a mono, basically a CLR platform, be very careful. Now, why is managed code awesome? Because from a development standpoint, it saves you a ton of time. In most cases, some people hate it, some people like it. I tend to be indifferent towards it, but the whole sort of point to it is that it saves developers a lot of time and promises other bonuses as well. But that for now, that's what we will. That's sort of a crash course on managed code in the context of using cheat engine to find values.